Hello everyone. Thanks for joining this session. I'm Shriram Sankaran, Senior Product Manager here at Syncfusion. The application I'll be showcasing is designed like a chat interface where users can simply type in a natural language prompt or select from one of the predefined prompts available. For example, something like investment portfolio allocation. The AI interprets this request, processes it, and generates an interactive chat using the Syncfusion chat component, all in real time. The response also includes relevant insights that provide more context around the data presented, like the one that you see on the screen right now. But that's not all. We have also enabled image-based input where users can upload an image by clicking the plus icon followed by the upload image option. Then they can select the respective image based on which the chart needs to be generated. The AI can then analyze that image and produce a digital interactive version of the chart within the application. This particular output also provides insights as we saw in the previous input of a predefined prompt. So in the next few moments, I'll walk you through how this works step by step and show you how easy it is to build such intelligent, user-friendly features using .NET MAUI and Syncfusion components, all powered by AI. Alright, let's take a quick look at what we'll be covering in this demo. To start off, I'll walk you through how we can integrate the AI engine using the Azure OpenAI library to enable natural language processing capabilities within the app. Next, we will dive into leveraging the Syncfusion Toolkit for .NET MAUI to create sleek, modern user interface that forms the foundation of our application. And finally, I'll demonstrate how we process the AI-generated output and convert it into a fully interactive, visually rich chart, all rendered seamlessly within the app. Excited? Let's get started and bring this app to life. Before we dive into the code, there are a couple of prerequisites you will want to have in place. First, make sure you have Visual Studio Code set up with the latest .NET MAUI SDK and workload installed. You will also need a valid OpenAI API key, which is essential for connecting your application to the AI services powered by Azure OpenAI. Now, when it comes to the OpenAI API key, there's one important thing to know. This library requires an Azure subscription with Azure OpenAI Access enabled. If you're new to this setup, I recommend checking out Microsoft's Getting Started guide for step-by-step instructions on how to request and configure access. For this demo, I'll be using my own Azure account, which already has access enabled. So we are good to go. Before we continue, let's take a quick look at what the Syncfusion Toolkit for .NET MAUI actually is. It's a collection of ready-to-use UI controls and productivity tools that help you build beautiful, responsive, and high-performance cross-platform apps. It comes with a wide range of controls like charts, calendars, and tab views, all fully customizable, easy to integrate, and designed to work seamlessly across Android, iOS, Windows, and macOS. So whether you're building a dashboard or a full data visualization tool, the Syncfusion Toolkit helps you get there faster and smoother, saving tons of development time. And for this demo, I'm going to use the AIAssistView, a special AI-friendly control from Syncfusion that lets us create a ChatGPT-like UI experience right inside a .NET MAUI app. Let's dive into the coding part. I'm going to start by creating a new .NET MAUI application, and I will name it Chart Generator. For that, I will open a new terminal and enter the command for creating a new project. Chart Generator is the name of the project, and it's been created successfully. Next, I will add the required packages by editing the CS project file directly. This includes the Azure OpenAI packages and Syncfusion MAUI Toolkit AssistView along with other packages we'll be using throughout the demo. The project has been saved, and let's wait for the dependencies to be restored. Now let's check whether the dependencies have been successfully restored. We'll open the packages folder. Yes, they have been restored successfully, as you can see on the screen. Once the dependencies are restored, let's go ahead and set up the Azure base service. For that, I'm creating a new folder named Azure base service right now. As you can see, I'll navigate to the specific folder right now. Inside this folder, I will add a new class called Azure Credentials. I'll select class and then provide the name of the class. The class has been created. This will be a static class and it's going to hold all the essential details like your Azure API key, the endpoint, and deployment model name. This setup will help us keep everything organized and easy to manage. Here, make sure to replace your key, endpoint, and deployment model name, which I'll be doing behind the scenes. Right. After this, I'm going to create another class named Azure Base Service for creating and handling AI client. I'll create this class right now. The name has been provided and the class created. First, I'll map the AI credentials over here. Following which, I will add a method which will be used to initialize the Azure OpenAI client for communication with Azure AI services. So the code has been added. Next, let's add the necessary namespaces to fix the issues. This particular method is a critical part of setting up the connection to Azure OpenAI services, allowing the application to make an API call for AI-powered chat completions. Since we are using Syncfusion libraries, we will need to configure them in the MAUI program.cs file. So I've navigated to that particular file. Under the Builder section, make sure to call Configure Syncfusion Core and also Configure Syncfusion Toolkit to set up everything properly. First, configure Syncfusion Core, followed by Configure Syncfusion Toolkit. Now, the controls are ready to be used. Rather than walking through the code line by line, I'll be showcasing the completed application along with its code and output. We will explore the project, which I've already opened, to understand the overall application flow and see how all the pieces fit together behind the scenes. I'll focus on highlighting only the key components and logic that power the app. And don't worry, source code access details will be shared at the end of the session, so you can dive in and explore it further on your own. At the heart of the UI, we are using the Syncfusion AIAssistView, and I've customized it to look and feel like a modern chatbot similar to ChatGPT. In the main page XAML, we have the main grid inside which resides the SF AIAssistView as the primary control. AssistView Editor View template is the main part which creates the ChatGPT-like UI which we just saw in the application. Here, you can see three different templates defined in response item template. The template selector will choose the template based on the AssistView item type here, where it's defined whether it is Cartesian or circular chart. Next, the flyout sidebar page is used to create the history tab similar to ChatGPT. In this particular app, the users will enter their request in natural language by either typing the prompt or selecting a predefined prompt. They can also upload an image too, right inside this particular AssistView. Now let's see how these three types of inputs are processed. Now I will move to View Model folder and open ChatGPT View Model CS file. Here, predefined prompts are implemented as chips in the header section. When a header prompt is clicked, the execute header sessions command method is triggered, which you can see on screen. This populates the input text property and sets up the UI state. User text inputs are handled via the AIAssistView's editor, with the input binding to input text, while images can be uploaded via the upload image option. When the send button is clicked, the execute send button command method is triggered. All inputs, predefined prompts, text inputs, or images flow through the send request method. This triggers the get result method, which is responsible for processing the input and generating a response. Now let's move to the core method of the chart generation process. Once a request is submitted, the AI engine kicks into processing. But here's the twist. We are not just sending the user input directly to the AI. Instead, we prepare a custom prompt and attach it to the user's input. getChartUserPrompt method creates a specialized prompt for chart generation. This prompt is carefully designed to instruct the AI to respond in a specific JSON format that you can see on screen. The next step is to send the prompt to the Azure OpenAI service. Since we have like 3 different types of inputs, predefined prompts, user text inputs, and images, let's see how they are like handled. For predefined prompts, the predefined text is sent directly to the AI service with the chart generation prompt. For user text inputs, text is formatted with the chart generation prompt before being sent to the AI service, whereas for image input, the image is first analyzed using AnalyzeImage Azure Async method. The image description is then added to the user's text input, and this combined information is sent to the AI with the chart generation prompt. Once we get the response from the AI, extract JSON content extracts JSON from the AI response. Once we receive the response in JSON, we deserialize it into a class object using deserializeJSON method. Based on the configuration, appropriate chart item, either Cartesian assist item or circular assist item, is created. Under extensions folder, as you can see on screen, Cartesian chart and circular chart has been like extended and necessary properties have been added. The JSON return is converted to chart config class. This class is bound to the chart that we have like defined. This object then becomes the binding context for the response displayed by the AIAssistView. Thanks to the response template of the AIAssistView, the chart is automatically generated and added to the visual tree. Finally, this method also generates a text explanation and animates the text response with a typing effect. Let me now show you how the demo works from start to finish. To begin, we just need to simply run the application. Once launched, you will see the chart interface appear. This is where users can type in prompts or upload images to generate charts. First, we'll make use of the predefined prompts that are like available to generate the chart. Now let's wait for the insights to be generated by AI. These insights are related to the diversification of allocation. Since this chart is related to investment portfolio allocation, we'll wait for it to get completed. Now, I'll create a new chart where the prompt would be entered by me. I'm going to provide my last week's sleep quality data to AI. The chart would be generated from this particular data. In addition to the chart, the AI also provides insights related to the sleep quality data that I've like provided. So we get the summary statistics, the daily sleep quality that I've like provided, the insights from it. It will also provide recommendations based on the data that I've like provided. There you go. The chart, as you can see, is interactive, where the labels are displayed whenever we hover on it. Next, we will upload an image to generate a chart. For this, we use the upload image option. Before that, we will just check what this image contains. This is the image based on which we want the chart to be generated. So now I'll proceed to upload this image. The chart has been generated. And there you go. We have the insights too. The insights are based on the data that's available in the image that was uploaded by me. Finally, we will have a look at the history section where all the prompts that were provided by me earlier can be viewed. This is one of my earlier prompts where a chart has been generated and is very much interactive, as you can see on the screen. And that wraps up the demo, and with it, the session as well. We have reached the end of our session, so let's quickly summarize what we have covered. Today, we explored how to combine natural language processing, custom prompts, and smart data binding to create a smooth, user-friendly experience where users can simply describe the chart they need and see it come to life. This approach not only makes data visualization more intuitive and accessible, but also highlights how the AI and the Syncfusion.NET MAUI toolkit can come together to power modern, intelligent applications. You will see a QR code on the screen now. Feel free to scan it and it will take you straight to the GitHub repo where I can explore the full project. Thank you so much for joining me and happy coding.